Okay, everybody, thanks for bearing with us and coming back from the first break. We have an exciting talk, and we opened up with a live shot out here in Breckenridge as the snow falls and continues to accumulate. It's more than appropriate to have this kind of shot to introduce our next speaker, who is Paul Kocin. Paul's a graduate of Cornell University and spent most of his career as a meteorologist for the National Weather Service in the Weather Prediction Center, formerly the Hydrometeorological Prediction Center. Additionally, Paul was on the air for 9 years as the winter weather expert for the Weather Channel and has co-authored the American Meteorological Society's publication, Northeast Snowstorms, Volumes 1 and 2. We all, I think, know that publication. It's kind of the Bible for winter weather forecasting, and is currently working on Volume 3, The 21st Century. With his breadth of knowledge of winter storms, Paul comes to us today to discuss the challenges of forecasting winter weather. Let's take a quick look at a little video. Might take you back a little bit, Paul, and then we'll come right out to Paul's presentation. Take a look.
I think there will be periods tonight where the sleet will be going back and forth with snow, but I think the sleet will be limiting some of the accumulations directly in the metropolitan area. But on the northwest sides of the cities, it's still likely to stay all snow, but we're going to see that progression
Thunder
of
for
warming.
me, baby.
I'm trying, Jim. But I'm not
Our
trying now.
experts, our winter weather expert Paul Kocin joins us now to tell us more about what's happening currently and looking into the future for tomorrow. We could be looking at a major ice storm possibly, right, Paul?
Oh, this really has the potential to be a great ice storm across portions of eastern Texas. Oh, and the reduced visibilities, we need basically 3 hours of winds greater than 35 miles per hour. The winds have not been that high yet. And the question... It is a pleasure to be here. I actually was once invited here during the winter season while I was at the Weather Channel, but because of my job, I could never come. So if this is what it takes to get me here, I'm very happy to be here. Matter of fact, I'm extremely happy to be here. Just having the ability to look out the window where I can actually see the snow coming down, that isn't something I get to do living in Washington, D.C., but I've had my moments. Anyway, my thing has always been, unlike Howie and his tornadoes, that winter storms are me. I'm very big into the historical aspects of it, and what I'm going to focus here is on where we've come in how we forecast these storms, where we are now, and I'm very fortunate that each and every winter I always got great new material. So, and you never really know what's going to happen, so I'll be presenting some of the things that happens. And fortunately for me also, we're not particularly able to forecast it all that well sometimes, despite a lot of effort that's gone into it. Now I'm representing the Weather Prediction Center at NCEP, and I'll be presenting some of the things that we do actually there as well. Now let's see. Okay, before beginning in the past, I'd actually like to start at the present, because I think that gives a better idea of where we are so we can see where we've come and figure out where we're going. Weather forecasts in general out to day 7 continues to improve, and the skill levels that we look for these forecasts are primarily due to the background climate, circulation, and patterns. So in other words, when there are certain circulation patterns, we can see these winter storms coming to fruition, and we have some pretty good confidence that they're going to occur. But there's some patterns where even as we get 1, 2, 3 days out, we can't really see, or we think we can see, but it turns out we have a lot more difficulty. And that represents one of the great challenges that we have today, is that we still, despite tremendous improvements over the last several years, we're not making a lot of important changes, at least in the short term, that we're actually trying to get a little better handle on. So the predictions of extreme events, such as blizzards, continue to get better, but they're still challenging. And I'm sure everyone out here has experienced, if you're forecasting in a market, not Miami, where you're dealing with winter storms, no consistent the models look, there are always going to be challenges that make these forecasts in particular difficult. And I have lots of experience with that, and I'll be presenting some examples. And one of the biggest challenges that I think has been going on in particular this field, at least with tornadoes, for the most part, you don't know exactly where they're going to hit, but you have some idea. With winter storms, there seems to be an expectation that we always know how much exactly where, and some people will ask you 2 weeks in advance whether or not, how much are we going to get right here? And the user expectations way exceed the science, and actually it's very difficult to communicate, even to fellow meteorologists, what we're able to do and actually what we can't do and what we can do. So anyway, the decisions made 4, 3, 2 days in advance depend on what's now called confidence-based forecast, which are based increasingly on ensemble forecasts and communicated directly to decision makers. And in recent years, we've had some forecasts, and my specialty has been on particular East Coast systems. They also, I know, get the most ratings, but they also affect the largest numbers of people around the nation. And some forecasts are successful from a forecaster point of view, and we have so many changes in that decision-making process in the days leading up to a forecast. There are literally hundreds, if not thousands, of changes that we can make to that forecast that at some point, yes, you'll get a successful forecast. But the reality is during that time leading up to the present, there are all these different issues that face the forecast, and we're going to have to become increasingly more sophisticated in how we communicate that message. And sometimes we're pretty good, and sometimes, oh man, it's really very tough. But advancements are still required to reduce uncertainty and improve the ability to communicate potential impact. So anyway, it is clear that we have much more forecast skill foreseeing these storms in advance than we ever have. In some cases, it's up to a week in advance, and I'll even show one case that was greater than a week. In other cases, we can't seem to really make a dent, even a day in advance. And the hardest thing is that we actually really don't understand what those differences are yet. In most cases, it's often a combination of the two. Some aspects of these winter storms are forecast great, others are not. I could point back to a day where I was forecasting for the Weather Channel back in December of 2000. There was a storm headed up the East Coast. The models the day before had no storm. The models actually had the next shortwave coming in, producing a storm. And then when the storm actually developed, the forecast for Washington was for heavy snow. The forecast for New York was for heavy snow. The forecast for Washington didn't work out. The big advantage for me working for the Weather Channel was that I could, every half hour, not talk about Washington and focus on those aspects where I could talk about it, which was in New York. And this was a case that was also forecast 7 days in advance, but it was when we got into the details of that forecast, for some places it was an absolutely terrible forecast, and other places it was absolutely great. So anyway, in general, as a science, we've gotten much better in forecasting cyclones. Now, cyclones are cyclones, and snowstorms are snowstorms. Snowstorms are often made up of cyclones. We forecast them pretty well, but cyclones are only one facet of when we're forecasting these storms. And the problems we mostly have when we're forecasting cyclones is that individual cyclones are composed often of mesoscale banding, bands of heavier snow embedded within these individual storms that unfortunately most of the time today are not particularly well forecast in the models. Models will give some hints of them, but often they're improperly placed and the science is not there. And I've got an example from the HRR, the HRR model, of one example where it actually forecasted quite well, but the confidence that we have in these forecasts is very slow, or very small. And precipitation type is also very problematic, and I've got some pretty recent examples of that, especially in the Washington area. And here's a picture during one of our great storms in Washington 3 years ago, Snowmageddon. That was taken in downtown DC. I was very happy to been there to witness that. But in general, for northeast snowstorms, we've gone from great uncertainty with a 1 to 2 day, with a 1 to 2 day forecast back when I was in school back in the 70s. Give you examples of that, to a 4 or 5 day lead time that's common currently, and that's only occurred in 30 years. So since I've been in the business now for 35 years, I've seen a tremendous amount of change, even though as you go from year to year, those changes can seem extremely slow and ploddingly, but the changes really have been very dramatic. A question that I can't answer is that why are some regimes seemingly more predictable while others are not? And I think that's going to become a more important focus of where research has to go in trying to help determine the aspects of predictability that I don't think we understand very well today. Mesoscale features and phenomena remain a dominant problem. Much of the heaviest snow falls in bands. Bands are right now a subject of considerable research in the field, very exciting things, but in terms of being able to predict these events, there's still relatively little skill that can be given to the forecasters, except in a general sense about we can expect them. And sometimes the entire event seems to occur on the mesoscale. You look at a nice model solution, you see this nice band of precipitation that's moving in, and for most of the time, the precipitation occurs in pulses, in little mesoscale occurrences. It stops, it ends, it moves, it develops. The dreaded dry slot will come in there, will end the snowfall really fast, and then the same dreaded dry slot will come through, and on the western edge of that, we'll be getting this back building of precipitation. So all of a sudden you think you've caught on the fact that the snow will end, and then all of a sudden that, oh no, it's not ending at all. It keeps building back, and instead of getting light snowfall, it becomes a big deal. So, some recent examples of forecasting these storms. Blizzard of February 8th and 9th, 2013. Yes, I know some people have named it Nemo. We'll just keep that separate. This was generally a very well forecast storm. No problem. I hope you didn't read an article in the New Republic recently. No. Good. Okay. This was generally a well forecast storm. Somebody obviously did. And presents some of the challenges we have because some aspects of the storm were really pretty easy to forecast. It was a really easy call for New England. Days in advance we saw it looks like the storm's going to dump about 2 feet of snow. So, people get very, happy, excited that we can do this kind of thing. But with every single case, there will be some elements that will be fairly predictable, and then there will be some elements that not. If you lived in New York City and Long Island, it was an incredibly difficult call because the snow was expected to begin as possibly snow, change to rain, change back to snow. There were all the questions of timing. And then there was this little mesoscale band that happened to crop up that may or may not have been visible in some of the forecasts. Chances are it probably wasn't. That made it a very interesting storm to experience. And I know when I was watching this, and I think I was working some other desk at WPC, it was really hard for me to focus on what I was doing and just to deal with what I was actually looking at on the screen. So I now actually work the winter weather forecasting. I'm back to it, so at least I don't have to get distracted. And I just love this stuff. So anyway, the larger precipitation distribution here across eastern New England, fairly easy, dramatic. The blues represent anything greater than 10 inches. There's your 20-inch band moving across central and eastern New England. And on the left-hand side, excuse me, a little more detailed view of some of the mesoscale aspects that I actually had a son that was working on Long Island, and I was telling him, get out, get out, get out, get out. But I didn't exactly expect what was going to happen. It was raining when he left, so he got out. By that afternoon, he was in islip. They wound up getting 28 inches of snow because this one little mesoscale band happened to crop up also into central Connecticut there. And instead of getting a 10 to 20 inch snowfall, they wound up getting a 30 to 40 inch snowfall. So these are the kinds of details that get in the way of, we look at the models and we seem to, we'll even think we see some model consensus, and reality is we are still playing somewhat of a guessing game. And there is no easy solution now, but I think an understanding of how these storms are actually composed and how they form and develop helps us to update our forecasts to at least rapidly respond where we have to and not make blanket statements 3 or 4 days out that we really think we know what's actually going to happen. That was actually the real beauty of the winter weather expert position at the Weather Channel, because I was given half-an-hour updates. And every half an hour, man, you could just change that snowfall graphic because you had to. And that was really a great thing to experience. Now I get to issue a forecast that has to go out one time in the day, 24 hours, and I have to be happy with that forecast for 24 hours. No, it's not going to happen. So anyway, for February 8th and 9th, 2013, if you remember, on the left-hand side of the screen, there was this little, it looks like a bright band, but maybe part of it actually was a bright band, but actually what it was just some tremendous mesoscale snowfall rates, 4, 5, 6 inches per hour, that developed, as they sometimes do, in singular or multiple bands, that we can see developing on the right-hand side. First, that's the bright banding that it goes there, and then that bright band transitions into the heavy snow where the rain is changing to snow. And then later on, in certain specific areas, the snow really becomes heavy. And also notice when you're just looking on the radar loop on the right-hand side, we look at models all the time, and some things seem to translate pretty linearly well, but all of these storms have some tremendous structure involved in them. And it's going to be really interesting how the mesoscale models can actually track some of these features.
Paul, real quick,
Yeah.
Dale from the Weather Channel, and as you said, obviously that band, and I happened to be at the Weather Channel helping with the forecasting at that point, and as you said, it's both a luxury and
It's a luxury.
it's a luxury to be watching it, but also at that point, if you look at that radar on the left-hand side,
Yeah.
we have a forecast of 10 to 15 inches out for Central Park.
That turned to
And
be pretty good.
right at that point, you were sitting there going,
Oh.
all right, here it is. There's this band setting up from central Long Island. That's going to track up into Connecticut. We need to bulk up our snowfall amounts there. What are we going to do with New York City? And you've got on-camera people. You've got other people going, you guys still have 10 to 15 in New York City. What do you want to do? And fortunately, because sometimes you can react too quickly when you've got 24 hours a day, every half hour to look at it. And it was interesting to watch that finally did fill in. And the forecast in New York City proper, it might have been more 8 or 9, but it did. But it was interesting there. You're like, okay, this is taken off. And if they don't get it soon, and it stopped backing, the band stayed over Long Island, but fortunately it filled in from the west, and that was getting scary.
I can be jaded and say, well, focus on New England where it's easy.
Yeah.
But the reality was, and I'm talking about, the system coming in from the left. What was that going to do? Was it going to fill in, or was it going to dissipate? And meanwhile, New York City is sitting on the western edge of this band, and the reality is it's an extremely difficult forecast that even as you're going through with it, you don't necessarily know. Some features sort of pop out at you, and then you've got some confidence. Other things, if it's over one of your big markets, you're in trouble, but so is everybody else. And these are the things, the good news, it's every example. So if you're from the Weather Channel or any local, Howard Bernstein from the Washington, D.C. area, every storm, right. Except I was there in 2009, 2010. That was easy. Yeah, that was easy. They were big and they were easy, and that's what happens with some of the really big ones. They're easy, but they're the ones that occur once every 500 years, and the other ones are all very complex. And I'll raise March 4th through 9th, 2013. One of the elements of this storm, and this is the snowfall depiction chart. So the white areas are 4 to 10 inches and whatever. You can see a nice band sloping southeastward across the Midwest. Then there's a break in eastern Ohio and West Virginia. And then bloof, it's another big blow up across West Virginia and Northern Virginia. But you'll also notice Washington, D.C. is just east of that more significant band. Too bad the forecast didn't really know that. Another interesting facet is if you look up towards New England, there's another area of very heavy snow. Well, was this storm the same storm that actually just, why didn't it fill in between? What's sort of going on here? Reality is most of these storms are extremely complex. They have different features going on. They're complicated. Sometimes we figure it out. And sometimes the details are incorrect.
Hey, Paul.
Yes.
Howard Burns in WSA. That storm, you can go back one graphic. If I recall, the QPFs that the models were putting out, we only got maybe half of what the QPF was out. And because we didn't get the snow rate, that knot of vorticity, there were 20 plus totals to our south and west, maybe an hour, 75 minutes to D.C. We were snowing, but it wasn't sticking because we just never got into that intense rate of snow that we were expecting. So the models in this case really misled us.
Right, which they always do. And
we'll just blame the models, right?
Well, the reality is that it's not just the models. We have so many versions of the models now with ensembles that it's very difficult to say it without talking in terms of probabilities. And another sort of bad reality, if you talk about all of these cases and all of the likely scenarios, most of these events, if you forecast between 0 and 20 inches for your area, you're going to be right.
I'm going to be fired.
And you're going to be fired, right. But that's reality, and we have to be able to figure out some way, which is only in communication, of how to deal with this issue when the public already expects you to have the answer 3 days in advance or whatever it is, because we've been giving them this garbage for years. And we're continuing to give it to them, and it's going to be very hard. It just is going to be hard. Yes?
I actually went pretty close to 0 to 20 in my viewing area in central Pennsylvania for that one, and they thought I was nuts. But that was a tough storm from the Laurel Highlands in southern Pennsylvania to near Maryland.
And
nothing north of I-80.
Yeah, and I hate to say it, many of them are. At least with what Howard was saying, I actually don't have to present a later slide because I try to explain why that forecast, and I think you're absolutely right. I'll show you the forecast in a second, but the White House, we're lucky that it snowed, actually. You can see all the accumulations on the ground in front of the White House. Yep. I decided to take a drive westward. I don't know what I was thinking. I wanted to see snow. Unfortunately, another car was driving on the other side of the road in Western Virginia. He didn't care as much as I did, so he slid into me. It's a good thing I have a used car. Not too much damage, but on the top right, that's Western Virginia. Very heavy, wet snow. The event that happened several days later, when the shortwave moved way out over the ocean, was tremendous tides across New England, and there was some damage where houses actually sank into the sea. I think it was called Plum Island for this one. Yeah. So I wish I had the same color scheme for each side, because on the left-hand side, that's the forecast the day before, NWS, and I was agreeing with them. And the observed on the right, basically you can see with the colors, red is above 10 inches. We were expecting 8 to 10. I thought that was, kind of reasonable. But if you look on the right-hand side and the scale is in the middle, you see that the pink colors basically start at 6 inches. And if you look at Washington, D.C., we had less than an inch. So 8 to 10 inches, you get less than an inch. Don't look so good. Why? As Howard was saying, temperatures in this case were marginal to begin with. Bottom line, the models in general forecast more QPF than observed, less vertical motion, less cooling. You don't get the rates. You know, the snow doesn't come down hard enough. It can't stick. We're too warm.
I was
Howard.
on the side of the verticals were going to overtake the cold
We
air,
thought
and
it
we
was
were
going to be
get it.
great. Yeah.
Crowder went for it. He was like, "Yeah, I'm going 10 to 15."
Yeah.
And it just. Then we watched Jim out there with the rain and went a couple of wets. Oh, it was a great day.
Oh, if I got other stories
Hey,
for that.
Paul, Howard Burns sitting on WUSA.
Oh, yeah.
I remember some totals, and maybe it's Rixieville out toward Culpeper County or somewhere out there. These folks had 20, 25 inches of snow.
Yeah.
And we're watching the rain change to snow and just saying, if it doesn't start piling up soon, we're dead. School's closed, and we took a lot of abuse.
Yeah. Oh no, it's I got to drive down 66 to see it for myself.
Just real quickly, they shut the government down that day, right, ahead of time?
I have a better example about a couple of weeks ago. Yeah.
I mean, I remember that situation and going back and look at it. I mean, we were essentially playing with 2 degrees Celsius.
Yeah. That's
Okay,
it.
that is it.
Right. But it's
And-
interesting how it really was the snowfall rates. You know, it's funny. If the snow's going to come down hard, it's going to stick. If the snow's not going to come down hard, it's not going to stick. That's the big difference. So it just didn't snow hard enough, so we got nothing instead of a little further west. It did. And that's how it always works. Yuck. But that's life. And more recently, we have more life. December 8th, the now infamous Philadelphia snow band. I was forecasting for that too. December 10th, 2013, I will admit I was mad because I got into work that morning. Government had been closed. I didn't know it. And my reaction was like, this was before it was supposed to start snowing, because I got in early. You know, why? And I think there is a lag in people's memory. They remember January 27th, 2011, when we have this big upper low, and we had this incredible snow bomb in Washington, D.C. that hit during rush hour in the evening. People had 12-hour commutes. This is what I think was in people's memories, but that was a storm that later produced 14 inches of snow in Philadelphia, 20 inches in New York. This was a storm that was supposed to dump no more than 3 to 5 inches of snow in Washington, D.C., with marginal temperatures. So they shut the government down. Anyway, I'll show that in a second. All right, December 8th, 2013, Philadelphia snow ban. These things just don't surprise anymore. They had about 9 inches of snow, up to a foot in surrounding areas, basically in a 4 to 5 hour period, due to this one little band coming across northern Maryland. Of course, it formed north of my house. I couldn't see it. And then went across southeastern Pennsylvania, across Philadelphia, didn't extend up to New York, didn't even extend down to Atlantic City. I'm actually the one who did that three-day forecast on the top level panel, where I indicated a 10 to 40% chance of greater than 4 inches of snow. Whoopee! You know, and that actually is a relatively decent forecast. It's sort of half verified. And even as you get closer to the event, 3 days later, I wasn't working it, sort of the same area, sort of the same thing. These kind of events can do it to you.
Paul, this is Dale Eck. I happened to be into work that day as well, and it was funny that nothing was there until, I don't think it really started showing up till right around noon. And if you remember from the Weather Channel, it's kind of like, okay, we put our forecast out in the morning and we track it, and up until about noon, then we shift into, okay, new forecast cycle kind of thing. And after I left, and I think we had like an inch of snow forecast for Philadelphia with this thing, which obviously wasn't good at all. And I talked to the guy who was working, and he goes, yeah, right at around noon, I bumped it to 1 to 3. And I said, fell a little bit short, didn't you? So it was, you got that one little band that it's where it met the cold air, and it just sat there. And
Well, it's not even where it met. This is how mesoscale bands form. And, in fairly innocuous situations, I do remember some of the models indicating some bands, and I'll show an example. It had banded structure. It wasn't correctly placed, but it indicated that there was going to be some banding with this. Try to figure out where. Well, it turns out that the one version of the HRRR, the High Resolution Rapid Refresh, that was initialized at 11 o'clock in the morning, I think it was 11Z in the morning, has the band. This is great. You know, it actually forecasts, and I'll show quickly. Here's the band that actually forecasts, you know, forecasting several inches of snow. So you have to think that, oh, I mean, having access to this is really great. But these models are produced every hour on the hour. And if you go back, which I did for this particular case, and I don't have much experience yet looking through the models, and you look at some of the models, nothing. Oh, there it is. Oh, nothing. You know, it's still a very difficult proposition, but it is rewarding that you know that the models at least are capable on a very short leash to predict features such as this, because we have to. This is the only way we're going to be able to improve, is if we're able to forecast elements like this, because we will constantly continue to get this kind of forecast bust time and time again until we can finally figure out how we can predict them. You know, snowstorms do not often like to be these nice synoptic scale, comma-headed systems with the snow starts and ends, it gradually gets higher, and then it ends, and, you know, that happens, you know, 1%, 2% of the time. And this is the 2 days later, so we're already dealing with, you know, here we go again, what do you think's going to happen? And it's not very good. And this is what actually happened. Here's the snowfall distribution across the Washington area. Look very close to the bottom, you'll see right in the middle of DC, 0.5 inches. And yes, to the north, you can see across Frederick County up north of Baltimore, 4 inches of snow. Was that worth spending the millions of dollars calling off the government just in case that occurred in the city? So I think in this case, I don't know how the decision-making process worked, but not having the perspective that this was going to be far different than the case of 2 years ago when that storm shut down traffic in the city. This was a little minor bump in the log that was basically due to the fact that the models, and this is the NAM, for what it's worth, their forecasting temperatures were 2 to 3 degrees colder than what they actually occurred, as you can see on the bottom of the figure. So instead of getting below freezing, we were near freezing, yeah, people got a day off. I didn't. January 2nd and 3rd, 2000, we're getting into this current year. Great storm. I really enjoyed it. I've never seen temperatures so cold in all my years in New England with a significant snowstorm. How often do you see it's snowing hard in Watertown and 6 below. It's dropping to 2 degrees in Boston. Were you there? I know, I did. It said 1. You were there. Ooh, that was a good one. And we're already getting reports of a foot and a half of snow, actually, I heard that, north of the city, when we're looking at radar returns of I'm sorry, I don't actually see that. So what we see on the left-hand side, and it's in clear air mode, you know, if you looked at the regular radar, the regular depiction, we wouldn't have seen much of the way that's going on. And yes, there are some nice pulsating bands that are moving to the north, and what happened north of Boston seemed to be very well related to an inflow of oceanic air. You can see even in the, right there across northeastern Massachusetts, you can see the elements moving in from the northeast. And certainly, in terms of thermodynamic structure, just look at the synoptic situation that's setting up across eastern New England. You've got northeasterly winds across southeastern New England, temperatures near 30 degrees, and meanwhile in Boston, this time was 8 degrees. There's a little bit of a frontal structure that's developing and undulating across the area. Matter of fact, there were areas that would drop 15 degrees, then rise 15 degrees, then fall, as this really amazing air mass got in place. So even though the snowfall returns, you know, we were getting very small looking rates, but we're getting information that it was coming down at incredible rates. And this is the real advantage we have of looking at weather observation, weather enthusiast networks. These guys, they're nuts, but they actually provide an invaluable service by showing us what actually happens. And they have great terminology too. One guy described it, and I understand it fully. We are now in full weenie mode. Weenie mode, this is what they wait their lives for, to see this kind of stuff happening. And, they have this kind of enthusiasm that can't be beat. And I got actually one extra new terminology, that it was so cold that a guy was getting snutsicles forming in his nose. So here it is. So here it is, January 2014. Challenges obviously still remain. Still very difficult to forecast meso snow bands. February 2013, the Philadelphia snow band, case in point. We still have some skill with precipitation type, but when it's marginal, March 6, 2013, the DC disaster, Snowquester, and December 10th, 2013, millions of dollars for half an inch of snow. But we have made lots of progress. Going back, now I'll go a little farther back in the 30s, 40s, and 50s, where all we had was surface data. I would have had a great time during that time. Russ knows this. All we had was surface data, increasing use of RAOB data after World War II. We started getting a little bit of the RAOBs in the 30s. Weather forecasting was easy. Stunk, but it was easy. The forecast process was subjective, was based on analogs and experience, and we had new models to begin to work with. Fortunately, one of my favorite storms is the so-called Appalachian Storm of November 1950, which produced 100-mile-an-hour winds throughout New England and New York, 30 inches of snow in western Pennsylvania, 5 degrees in Atlanta, Georgia, and this is November. Cold air moving in on southerly winds, warm air moving in on easterly winds, puts the March 93 superstorm to shame. Here's the evolution of that storm. Big cold outbreak. If you look at the top level, we're going down from left-hand side to middle to the right, and you'll see a low-pressure area develops in western North Carolina, moves north, near Washington, D.C., then moves to Cleveland, Ohio, then kind of spins around, kind of like those tornado vortices. Maybe one day we'll even see an anticyclonic moving, maybe not. Snowfall from this storm, not trivial again, where it's light blue and dark blue, 10 to 30 inches, red is 30 plus. Across West Virginia, snowfall amounts up to 60 inches. And the reason I'm bringing up this storm in the context of showing our evolution of forecasts is that the storm of 1950 was one of the first storms to be modeled by scientists. So if they're ever going to pick a storm that, here, let's try to forecast that one, it's like, oh my God. Try doing this one. But it did start the era of numerical weather prediction, which is the first of what are probably two major revolutions in forecasting that's especially applicable to winter storms. First one, development of NWP, and the second one, of course, is ensemble models. Okay, computing capability has changed over time. That's part of the reason these things have changed. Top panel back in 1946, lots of vacuum tubes. They failed on occasion. 5,000 additions and subtractions per second. Whew, that's a lot of adding and subtracting. Nowadays, the IBM, who knows what they have now. I'll have to talk to Louis. 73 trillion calculations a second instead of 5,000 additions and subtractions, 3.5 billion observations per day, and 27.8 million model fields per day. Now, we do like to look at all those fields, but I think it's going to become increasingly hard for us to look at that kind of information. I'm being half serious here. 27 million is a little ridiculous, but as we get more ensemble forecasts and more model output, we can't just look at an individual model field and say, this is what's going to happen. We just can't. So it's going to change in ways we don't necessarily yet understand, but we know it's going to change. So anyway, here's a paper, an image from a paper that basically started out some of the forecasts for these extratropical cyclones. It's a paper by Charney and Phillips back in 1953. And since then, the advances in numerical weather prediction, we saw those first forecasts around 1950, the first 3-layer model and 6 or 7-layer PE models before my time in the 60s. Now we're getting to my time, the LFM, some called it the laugh-a-minute model back in 1971, and the first global models back in the mid-1970s, where basically all you can say about these forecasting, even a day or two out, it was an adventure. And certainly when it came to forecasting winter storms, you could have something that was coming the next day, and it's like we were hopeful, but we were clueless. So the 1978 New England blizzard was forecast, remarkably, again pointing to the fact that some of these storms seem to be more predictable than others, while the President's Day storm, number 1, in 1979 was not. So back in 1978, imagine all we had was looking at surface maps, and you're looking at the top left panel as it was not too much before this period of time. So you see that there's a big cold high. Yes, it looks very cold and wintry, but there's a 1025 low and a cold front going through the Midwest. What can happen out of that? Well, it turns out the forecast, the numerical model forecast for this, saw this thing developing off the coast that if you had been based sort of just on extrapolation of surface features, no chance. I mean, you could predict something because you've seen, with cold air in place like that, but not the kind of development we saw with the blizzard of 78, which turned out to be one of the big storms of the previous century. And here is the 84-hour forecast, an 84-hour forecast in 1978 that we laughed at because, that'll be funny, And there was on the right-hand side is at 72 hours, the manual prog they developed basically off of those forecasts at my predecessor organization. And oddly enough, 3-day forecast, it verified. It happened. Not exactly, but the idea that it happened, this was actually big news back then. Today, it's nothing, really nothing. I mean, we bombed today, but for different reasons. But before, and this always seems to happen, and always seems to happen to the NWS leader, Dr. Uccellini, just when things look like they're going great, the next storm comes in and thwap. The models don't do it. So here was the first President's Day storm. There is going to be a 35th year retrospective this year, anniversary that was supposed to be held next month. It's been moved up because this storm actually galvanized some research that helped predict these kind of surprise storms with a lot of research into diabatic jet dynamics, et cetera, that there are a number of people in the field that have based their careers off of this. So people went to bed that night, woke up, if they slept late, they woke up to clear skies after a forecast of 3 to 4 inches of snow and found out that they instead had 2 feet, of which half of which, if not more, fell in about 3 or 4 hours. It wasn't predicted even hours in advance. Those forecasts are shown on the right-hand side of the screen, showing a little amorphous low, pretty decent Vort max coming through, but just a fairly innocuous cyclone coming through, maybe a few inches of snow. That didn't happen. Which leads up to today, 1980s, better data assimilation and better representation of physics. This is the days of the NGM and the AVM. 1990s, more resolution added, the ADA ensembles were introduced, and many models are run out of universities and research centers where ensembles finally are more common. And the computer power, of course, is increasing all the time. Another example of forecast success was the March 93 superstorm. And if you remember that, top panel, surface evolution, incredible low develops in the Gulf, 970 low in Georgia, moves up the coast, just incredible. Snowfall on the lower left-hand side, probably the largest distribution of heavy snowfall in modern records. I've looked at a lot of cases. I can't see anything that really exceeds that to that degree. And of course, a very interesting satellite signature. And then there were the forecasts at the time. Now, I will say the LFM, before it was cut off and killed, was run for this, and I got to see it. It forecasted too. But it just points to the fact that there are some regimes that no matter how good, bad, whatever your models are, they're going to get it. How? Why? What? I think that's coming. So it's a huge and intense storm that was predicted not 3 days in advance, as was 15 years before that, but 5 days in advance with surprising consistency, and that has been a key term, consistency. Although I can argue there are very consistent forecasts now that still turn out to be wrong. They're just consistently wrong. During that day, a consistent forecast was a sign that, the models are saying the same signal day after day. And the details of who got snow, sleet, and rain were not as clear-cut until we realized that. But if you look at all the forecasts, 60, 48, 36, 12-hour periods leading up to the storm, they basically show the same thing. So clearly we're in a new forecasting regime. That was continued 3 years later with the blizzard of 1996, another incredibly well forecast for the most part, not as well forecast as the 93 storm, but I always liked the fact that if you look at the initial analysis for forecasts on the left-hand side, 12Z the 6th of January, and you're getting 36 hours later to that solution with a big cyclone off the East Coast, that we've got the models on the right-hand side that are doing exactly that. So this is just my own sense of like, wow, we've got that capability in advance to see these things actually occur. So we can predict cyclones pretty well. And in this case, it was one great cyclone. So just when everybody's again getting there like, yes, we can forecast 5 days in advance. We've got all these big storms, and I think there was the No Surprise Weather Service. There comes January 25th, 2000. No storm becomes big storm. So we still have lots of room to improve. December 30th, which I talked back before, and I probably don't need, but I included it anyway, March 5th and 6th, 2001. I think Jim was jeered in New York City. Sorry. And this was also my first, yeah. It was also my first couple. But these were my first days like working at the Weather Channel, and this is what I'm given? Wasn't good. All right, January 25th, 2000, top left panel indicates a 3.5 day forecast versus the red is in reality, not so good. The medium range, the MRF at the time, if you remember, had the possibility of a significant East Coast storm, but from a different shortwave. Short range, once it got to the right shortwave, the models were too far east until 24 hours or less. So if you look at the forecast 24 hours in advance, looking at precipitation amounts, see Washington right in the little bit of greens and the heavier stuff farther east. No, that didn't work. However, this was right at the start where some of the meteorologists working in the EMC at NCEP were working with ensembles and trying to figure out a way of how we can just help describe and put information from them out there. We got several signals from an ADA ensemble forecast. Most of the signals had, just like that one ADA forecast showed, most of the precipitation staying south of DC. It's only a 24-hour forecast. But some of the ensembles, if you look farther up, indicated for 1 inch of melted precipitation, there were a couple of members that actually showed it. So yes, while given the paradigm for forecasting these things, you'd have to give it a low probability, but it still wasn't that it was not part of the solution. It was one of the solutions, just not a high probability. So that's another place where we've gone. December 30th, forecast, top left, DC is in it. The reality, DC's out of it. March 4th to 6th, 2001. Originally it looked like a big snowstorm in North Carolina. Eventually it snowed hard north of Boston. Phasing gone wrong. But the last few years have been okay. President's Day 2, 2003, thank God, it was pretty clear that that storm would occur. January blizzard of 2005, no major surprises. February 2006, New York City's biggest snowstorm on record. We didn't forecast all that much snow, but it wasn't a surprise. I think I'll just go through these sort of quickly, save a little time. February 2006, I will go to that one. How quickly things do change. 5-day forecast top left, 4.5-day forecast top right, 4-day forecast bottom left. And you'll notice things can change and sometimes do. No storm, oh, big storm. And after that, it was pretty much big storm. So anyway, getting to today's forecast process, it's no longer just surface data, simple models. The data is multifaceted. You get marine observations, aircraft, wind and temperature, satellite temperature, humidity, ocean and ocean surface winds, Raywin sondes, microwave soundings, and the forecast process is now objective, based on numerical models, with lots of interaction between national centers and the local forecast offices, and even interaction between public and private services. So, getting back to where we are, more current, I've posted all of the challenges. Let's show a few successes in the era of ensemble forecasts. And this, we didn't even really need those ensembles, but they helped. Snowmageddon, 5 to 6 February 2010, 20 inches of snow in Washington, D.C., 20 some odd inches in Philadelphia, virtually nothing in New York. And the model sort of had that. There was certainly a question whether it made it or not, but that kind of information probably would have been impossible in years advance. This one wasn't bad, not bad. The evolution is pretty classic when we get to East Coast snowstorms. Surface high, cold air locked into the northeast, low developing in the Gulf of Mexico. Look on the top row, you can see as that high moves eastward, another high builds to the north. That's your reinforcing shot of cold air. So no high moving off the coast, changing to rain kind of issues in that sense. And the storm system develops and follows a track slowly up the coast. The best slide I have, February 1978, a 3-day forecast, March 93, 5-day forecast. Yes, this is the European. I could have shown the GFS2, but the GFS only got it on day 7, not day 8. So this is an 8-day forecast issued on January 28th for February 6th. Forecast is on the left-hand side, analysis is on the right-hand side. Damn, you can get a pretty big swelled head for that one, especially if you believe it. In this case, it did really well. While that storm was actually going on, the forecast showed, while the snow was still falling, that another threat was coming up. 4 days later, this time I am using the GFS, you can notice on the top left, 6-day forecast, But as we get to a 4, 3, 2 forecast on the middle and lower panels, the analysis is on the right-hand side. Notice in the thickness pattern how it changes from the top left to the fact there was a little bit of a bowling ball in thickness that represents a very intense upper-level low that generated this next cyclone. Also predicted fairly well in advance.
Paul, real quickly, and it's kind of evident on that, and I guess it's a trend that we, tracking through the years as you look at, days 5 and beyond, trying to get a feel for, is there anything big out there on the model trends? And it seems like, I mean, just as a generalization, it's not always that way. The GFS tends to be more progressive, because if you look at that, it's definitely showing a progressive system there on day 6, where the European tends to handle these more, it gets that things may be a little blocked more and a little more higher amplitude, and I think that's why it has the storms like, you know, Sandy's the classic example. It had it way out in advance, and the GFS eventually caught up. So
Right.
I don't know what it is, but there seems to be something in the physics that wants to keep, you know, the general westerly progression, and
Right.
the GFS is a little more, it takes more for it to depict something closing off or cutting off in the day 6 to 10 range.
Right.
I don't know if you've, what your thoughts
There,
on that
there
are.
is some of that that seems to ring true simply because the European, in many instances, does seem to catch on earlier. However, that said, the next case I'm going to show is one case where it didn't.
It's not 100%.
No, it's not
This is the
100%.
time You're like,
And
I'm on to the European.
I'm right, we
He's
got
my
it.
guy, and
Yeah, he's my guy, and like, oh, he done me wrong. And
I believe these are supposed to be interactive sessions where
ooh,
we bring up points and debate.
would you like to? I can move off. Actually, I have to. What
The
time?
floor is yours.
All right.
It's 11:15. I guess you've
Got-
about a half an hour.
Oh,
before
okay.
questions.
All right, good. This doesn't show it very well, but you know, I haven't worked at the Weather Channel for a long time, and it was not an easy transition, but I do have to thank them because I was there for this. I was in Washington and not Atlanta. You were probably here. Vancouver. Oh, this was really a dream come true. You know, I think Howie can understand this from a tornado perspective, but this was the best, just the best. In a place I never really expected I'd see it. 40 to 50 inches of snow in 4 days with 2 little systems before that. So whenever anybody, oh, it never snows in Washington, D.C., and it's true, ever since then, we've had nothing. I don't care. I just don't care. You know, I've been through that. I know it could happen. I've seen it. You know, I'm happy. I can die happy now. So give me another inch of snow. Give me this on occasion. I'll be fine. So this was the probably the best 1-2 punch or one snowstorm I've been through. You know, and I know you wait up here for another 3 weeks, you'll see something bigger. But for something in the big cities like that, it was just awesome. It was, yeah, that's all we need. Now, this is a photo I took after I finally was able to get a ride home after the first one. So imagine you're going to put the blizzard on top of this one. The other one actually got lower visibilities. But I think I was probably trying to make a point on this. Oh, yeah, the radar. So anyway, I just want to demonstrate the difference in these 2 storms. This is the Snowmageddon. We'll start it from the top there. Just well-behaved snow banding coming in from the southwest. You can see eventually we're going to get some bright banding along the southern edge. Got really close to DC, it never made it. And then we get back towards in the Comma Head where it's no question we're just going to get snow. And the orientation of the began's been to shift as the Comma Head begins to shift south and then eastward. And many of us are very satisfied. And then we get 4 days later, unforecast initial burst up to 6 inches of snow ahead of the system. That was the bright banding. It changed to rain. Southern New Jersey, we had sleet in DC. But that bowling ball coming in from the west, look at the change in the orientation of the snow bands as it's coming around as the upper level low is going to the south. And eventually, with New York, which missed this storm, missed the first storm, got into this one. And we really in DC thought we'd be on the western edge of it, which we were, but the western edge was great. Matter of fact, the sun was out in like Alexandria, and I was about 15 miles away, and it was just blizzard all day. So how much better can your day be? Yes.
Hey, Paul Howard, Bernstein at WSA. This was also one of the few storms in D.C. when we went to a northwest wind. And normally, if we go to a northwest wind in D.C., we're
You're
done.
dead.
We
You're
were picking
toast.
up 1.5 inches of snow, still with a northwest wind, which I've only been there 13 plus years now. Have never seen that. May never see it again.
Right. There. Yes, thank you. Oh, you can hear. Thank you.
And
It's
one
not
other
the only
thing,
time.
real quick, Paul.
Yeah.
I was forecasting in Baltimore during those years, and this came after we already had a massive storm in December that had
Oh, yeah.
blizzard warnings with it. So this season wasn't just these two storms. It already had 3 rounds of blizzard warnings in the Mid-Atlantic. It was just absolutely incredible.
Yeah, I didn't mention the other one, but I didn't forget. Yeah, it was really pretty incredible. And I know I'm supposed to have I'm showing that for a reason. Oh, yes. With all these good forecasts, states were able to declare states of emergency, states and states of emergencies, days before the snow even began, which I would assume is helpful to budgets. The airlines canceled thousands of flights at least a day in advance. Stores adjust to optimize retail sales and disaster declarations, which facilitated, I think I left that out, snow removal. While these storms do represent successes of individual model forecasts, there are many others for these cases as well, and others, that weren't quite so successful. And we're getting back towards the ensemble concept. Even though we're looking at individual forecasts, the next case I'm going to be showing is an example of where ensembles are good and ensembles are not totally the answer. Almost all forecasts are uncertain to some degree or another. Your success or failure should not be tied to any particular model solution unless it just happens to be the right one, which we don't know until it happens. Plus, there are now more versions of models out there, roughly at least 150 to 200, and that number's increasing all the time. I could have showed lots of little postage stamps showing each of the individual. That's going to become increasingly difficult and pointless to do. So there needs to be a way to talk about predictability and uncertainty with respect to all of this new information that's coming in. So the ensemble model approach, the second revolution, final revolution in forecasting. Well, it's not the final. Please, don't be the final. All right, weather forecasting, it's impossible to be certain all the time. All forecasts contain errors that increase with time, and the large-scale predictability may be, right now, at best about 10 to 14 days. Ensembles are a collection of models providing information on a range of plausible forecasts, statistical measures of confidence that extend predictability. So ensemble models provide a range or envelope of possible solutions, and the spread of those solutions can be used to provide the probabilities or some confidence limits on what we're expecting with the forecast. So an envelope of solutions we're expecting, this is just a very simple example of a forecaster's dilemma on track of the storm. The initialization of today, you've got 2 tracks. Most likely you'll have dozens of potential tracks. There's work that's being done with trying to focus on the most likely solutions, not just either or the primary mode of solution, or hopefully you can get it down to forecast possibility. Number 1 and number 2, that's simplistically based on a change of track. It's going to be much more complex than that. But those are the typical kind of dilemmas we face. And that dilemma was emphasized back in the blizzard we had in New York City, same year, 2010, that December. You noticed all these years, they're good. There's a lot of stuff going on. Lots of snowstorms. So the snowfall totals from that storm, very narrow band of heavy snow, but it was focused right on northeastern New Jersey, New York City, blizzard conditions, 20 to 30 inches of snow with wind gusts up to about 75 miles per hour. My kind of storm. Here's the evolution with respect to of the storm as it moves up along the eastern seaboard. Fairly classic, at least in that way of depicting it. And like many other cases, Here's a surface analysis at its most intense stage, a 962 millibar low off southeast New England, and we happen to issue at WPC a 6-day forecast verifying at the same time. No problem. We've got this storm in the bag. Oops. Well, that was a 6-day forecast based on a series of models. Not too many to choose from, but you have to make a choice. So you're getting closer, you start increasing the numbers of systems you look at, and it turns out, even when you're looking at the operational models, this is where the GFS and the Europeans start to go, oh, I think we're going to diverge on this one. Remember those things? Some storms are more predictable than others. This one, not so much. So in blue is the actual storm track. In red, yes, the European, handy dandy, it's got it in the bag. GFS, the lowly GFS in green. Both cases here, red and green, no cigar. So this is 4 days in advance. 2 to 3 days in advance, we're going to write it all off. The light blue is the actual storm track, and now all of the different operational models, all of them out to sea. Whew. We don't have to worry about this one. It's done. It's toast. Oops. Then, to make things even worse, getting from 12Z, we're getting close to this storm because it actually started on the 26th. The observed is in blue. The European, the 0Z and 12Z runs in brown and red. Out to sea, the GFS is bringing it back. What do you believe? The GFS. So just to show you, it's a more complicated world out there. So as we got closer to the event, more and more models began to cluster. So here's 3 days prior on the top right-hand side. Everything is out to sea. There's nothing. 2 days prior, there's a lot less spread. And look at the spread on where all the surface lows were indicated by the colored symbols. They're all over the place, but they begin to converge 2 and basically 1 day prior. So basically a day and a half out, it's like, oh, I think they're going to get it. So as we get towards day 2 and day 1, we had a little better idea that this storm was going to be a hit. Impacts. Oops. Just like the earlier cases, that amount of forecast update, even a day to 2 days in advance, was enough since they'd been told there was this thing, maybe, maybe not. Yes?
Are you done with the ensemble part? Because I have a question about that.
Yes, go ahead.
Okay. My name's Ned Gardner. I'm with the Climate Program Office at NOAA. And I'm wondering, what's the future of the concept of probability with these ensemble models? Would you foresee using some kind of Bayesian methodology where different storm system types favor different models, and you put more weight on different models depending on the performance of those models under different conditions? And how should people who are not deep in the weeds like you take and interpret what's being provided in terms of the individual runs and ensemble, as well as the ensemble?
I don't think there's an answer to that yet, except I think that's the direction we're going. So I don't even have a good idea about the specifics. Probably Russ and others, Howie, probably have a better idea specifically about where it's going. But it's going in that direction to at least provide more information on much more information that we can't possibly, to try to actually simplify it. So whether we have confidence, and to say for a storm that's clearly, the models seem to be focusing in on that, we have a lot of confidence. That would be real nice. Versus the ones where we start to talk about, we don't have so much confidence in this one. And there's a distinction between one versus the other. Same kind of storm, but there's some signals here. If we can get to talk about that in terms of confidence and predictability, I think that's valuable information. It was valuable enough information for the airlines that they knew there was something coming, that they didn't jump on it days in advance, but when I think it was communicated to them that this was real, this looked much more certain at this point, that they were able to take action, and it was action that was valuable.
Paul, a quick follow-up. This is Chris Strager, National Weather Service, and that's one of the things that we are working on now, and that what you were talking about is the uncertainty, and with so many ensembles and different models and solutions out there in the out days, we're working on that national blender model team now for days 4 through 8, that we're trying to pull together a method to get a consensus based on these things that you're speaking about, verification for the models leading up to that event, which model is acting, how would you say, behaving the best as we go through this event or approach this event. And that's the one thing that we want to get out, to get that consistency too along the coast, because you know the way it is now with all the offices along the coast, there's a little bit of a difference in timing than wrapping that up with the winter weather desk at NCEP, at WPC, all working together to get out to that 4 to 8 days. So as you said, when we want to do this weather-ready nation and have the impacts there, we can come out with a consistent picture for that day 4 to 8, and we all know it's going to change. But when it changes, not if it changes, but when it changes, I like us to be all in sync as it comes up the coast and it goes back and forth. So long story short, that's what we're trying to do now, is to have that single picture so that the individual meteorologists, forecasters don't have to go through and try and pick out, well, this one ensemble model was good, this other one was bad.
Right. Thanks, Chris. And getting back, in New York City, which did not declare a snow emergency despite blizzard warnings about 14 hours in advance of the start of the snow, it wasn't enough time for them for it to make a difference, and they had an incredibly difficult time trying to deal with this. Several people lost their lives. Of course, the emergency vehicles couldn't get through because there wasn't this consistency that was working together. So this was one case. The ensembles were giving a picture, didn't give the whole picture, but sort of shows the complexity that we're dealing with and the decisions that have to be made every step along the way. That's going to have to become much more well coordinated. What we did see for the case was the potential was there 6 days in advance, but there was low confidence about the model predictions. Blizzard warning was issued in advance, 14 hours. Special efforts were made to emergency managers and airline industry prior to get the information out. The airline industry did take action, but the snow emergency wasn't declared in New York. And that turned out to be, successful forecast, yes. In many ways, no. In a lot of other ways, sort of in between.
This is Dale Eck with the Weather Channel, and I think this is one that you're working on, which is we can make forecasts, we can make good forecasts, but unless those who have to implement actions, and it was a classic case where having people on the road, we were in between winter weather experts at the time, so I was the one that they threw on the air. And I remember saying, between noon and 8 p.m. from central New Jersey through New York City, you do not want to be on the road because it could be life-threatening. And that kind of information, like you said, if they had pulled the snow emergency, which means you're not supposed to be, you get your car off the roads, and that was where they got caught. They didn't do that, so no one took any actions to obviously get their cars out of the way to plow the roads.
Right.
And there were too many people on the road. It's
right.
the day after, even though it's a weekend and a day after a holiday.
Right. There were a lot of things that played into it. Because I worked on a study. I'm trying to. The things that played into it were they'd had a number of blizzards in New York before. They seemed to handle it really well. In this particular case, they didn't. They also had blizzard warnings for those cases, and they're fine. This was also a blizzard warning. We're tough, we're cool, we can deal. But like you said, it was the day after Christmas. There was a huge number of people out there. There are all these individual factors that always play into these forecasts. Chris?
And just Chris Drager again, just one quick point. And Dell, and I noticed, Paul, mentioned on there too, success with the aviation. We did a special thing on that, and I see this coming up in the future too. On Christmas Eve, I remember that, we had a special conference call with all of the offices going up the East Coast for the terminal aerodrome forecasts, the tasks. We never did that before to that extent. We had it to the hour, all the way up the coast, on when the visibilities would go down and the heavy snow would start. And that was that one consistent message that got put out to the users, and they took heed. Thankfully, we knew the travel day, of course, you don't want to be doing that, but that was successful.
All right, this is where I'm ending. My own organization, where I work, and what we're doing to improve our ability to address, in particular, ensemble forecasting. What we do, or what we used to do, and we're still doing, we do an internal NWS collaboration, 24, 48, and 72-hour probabilities. Like I said before, I don't get to update every half hour. Miss it, not that much. Compute probabilities. You're familiar with the information on the right-hand side with the 10 to 40%, 40 to 70. We've changed that for this year, and now you'll see ensemble envelopes for different snowfall amounts that you see the information on the right-hand side. Tracks for surface lows, and we also produce a heavy snow discussion. My job is actually to produce, surprisingly, a deterministic forecast, which really kind of pisses me off because while everybody in the Weather Service, I spend a lot of time. Everybody in the local offices does get a chance to see this, but the public, nothing. And I'm good friends with the programmer and developer of all this. What's that?
I tweet that probabilistic out all the time.
Okay, good.
I take pictures of it and cut it so they see it.
No. The problem, that's fine, but you still do not see mine. And this is just a very personal, it's just personal. Now, this probabilistic is a wonderful improvement, and a big improvement over what we had before. So, and ultimately, that is what we produce from our deterministic forecast is included as one of many members of an ensemble to generate those probabilities. So I spend any number of hours, Paul Kocin talking, to generate my favorite forecast, and then it's just one component of all of that information. And it isn't all, but it's a significant part of the information that goes into making that forecast, which is an automated process from a 33-member multi-model ensemble. And our forecast is considered the mode of the distribution, and I get my ego out of it and said, it actually counts. So what we do does matter. I'm not showing the graphic for day one, which shows that we do worse than the automated ensemble forecast, but I will show the day 3 forecast that actually says that our improvements do help. Really, the progress that has been made in generating automated forecasts from an ensemble model suite really sometimes gives us some pretty damn good forecasts. It's really kind of nice to see this after years of, I don't know how to do this. It's working well. Changes that we see in our organization for this year, we've expanded those probabilities on the website. We tested it out last year, it's now operational. The probability forecasts are provided in Google Maps and cover a 72-hour period. And this is where the forecast membership consists of our deterministic forecast, 20 SREF members, the GFS, the GEFS mean, 5 GEFS members, the European ensemble mean, Canadian global, UK Met. Undoubtedly, all of this will be increasing in coming years. And these are just examples if you're ever looking at our webpage. We give forecasts in 6-hour time steps. You choose your own forecast duration, and for various snowfall amounts, 1, 2, 4, 6, 8, 12, whatever. So more flexible than it's ever been. And we're also doing experimental forecasts for day 4 to 7, which, and this says if forecasting winter weather is viable for day 4 and 7, it is. It is. And actually, the product that we're testing, I think, looks pretty good. An example, here's a case that occurred in late November. Here's the winter storm warnings that are shown for this particular case. This is the kind of product on the lower left-hand side that we're producing, which are probabilities of winter precipitation, basically greater than an inch of snow. And you'll notice the scale is on the left-hand side, 10, 30, 50, 70, and 90. On the day 7 forecast, hopefully you're not going to see 90% probabilities. So the fact that in this particular case, you do see a 10 and a 30, actually I think provides some pretty good information, really good information, and the information that really counts. So we're doing the internal testing this year and hoping to aim to go, not experimental, operational, a bug, next year. Okay, with a few minutes left, some personal musings I will end this on. Snowstorms are frequently fairly chaotic events made up of several QPF episodes or pieces that don't match well easily with model forecasts. In other words, they're all mesoscale. Most of them are mesoscale in the fact that we always look at these things as developing. The snow develops. Most of them, it's all pieces. It's this piece, that piece, it's all mesoscale. In well-developed cyclones, do we see the classic comma structures that we all hope for with each snowstorm? I've said it before, they probably occur in 1 or 2% of cases, and even in those cases, they're plagued by these very poorly predicted mesoscale bands. The models may look great and have a consensus for precipitation amounts. That's terrific, but they're almost always wrong. Forecasting more than 12 hours in advance is no longer an art, and I do miss those days. Not that much. Nowcasting, now that's where I really have my fun. Looking at the radar, looking at the surface ops. Basically, trying to figure out in your own head whether the models are doing right or where they're going wrong. That to me is the heart of forecasting now. And that's where the words are value add, I think, work the best. Where does the dry slot end and the back building begin? And because I know Russ is here, we look at the SPC mesoscale discussions. I would have said that even if you weren't. There are too many charlatans out there claiming to forecast winter weather. I don't have to name names, but many of you in here know. Oh. I won't. I promise. No, some forecasts are very easy. We'll talk in private. Some forecasts are very easy and others are very hard. They often are the same case and occur 10 miles apart. Damn it. Did I say that? And finally, don't ever ask me for the upcoming winter forecast. Ever. I'm done.
Okay, Paul, thank you very much. This is terrific. We have about 15 minutes for questions. So if anybody has questions, please raise your hand and we'll distribute the microphones accordingly. Dale has a microphone, and then Howard.
Oh, you're
Just a quick question.
Yeah.
A lot of times the experimental stuff is out there somewhere, and going to the HPC site, I don't see the date.
day 4 to 7.
No.
This is even pre-experimental.
Pre-experimental. Okay.
Right, so maybe that was correct. We'll go experimental.
Actually experimental.
yeah,
Okay.
yeah.
It would be nice to see those. So.
Yeah.
Okay, thanks.
Yeah, well, it will be if they're good.
Howard Bernstein, WSA, practically neighbors with you, Paul. You've been around this business for a while. In your opinion, what is it going to take? Because we get burned in the D.C. area by these mesoscale bands constantly. What do you think it's going to take, and is there a time that you see in the future where we can actually have some competency in forecasting these mesoscale bands and these chaotic events as you describe them?
Without knowing the details of the science and the physics involved, I can't answer. However, having been in the field and seen the changes over 35 years, where 20 years ago I couldn't imagine that we have a 4-day forecast that's believable, I don't see why we can't. I mean, there may be technical reasons why we can't, given budget constraints, but with the way things have evolved, I just think we were able to recognize it 20 years ago. We couldn't see them before we had the radars, so now we know. And all we have to do is be able to figure out how to predict them. So yeah, I'm optimistic with that. How much time, I don't know.
Jim Cantore, Weather Channel. Paul, I love forecasting winter weather. Right or wrong, it's about the game. You know what I mean? I mean,
No,
you
I
just
don't.
gotta,
Jim,
you
I
just
don't
gotta
know
go
what
for
you're
it.
talking about.
Yeah, I love doing
clue.
it. I'll keep doing it to the end of the time. But love the probabilistic ensemble forecasts. Going out 72 hours, if I've got to let somebody know where it's going to snow, that's the best tool. What would be nice, maybe, is to be able to sector that in some way, even on the Google map. Is that possible?
Sector, I'm not sure what
In
you're
other words, you can zoom into it, but you can't take a cut of it and like share the URL of a close-up. Like, let's say I just wanted to show the 72-hour probabilities for snow in the southern Appalachians. I can zoom in on it nicely, and I can see everybody, all the towns
You
show
can
up.
always write an email,
Oh, okay.
to-
Well, we can do that.
to
Fine.
the developers.
Does that mean it gets done?
Yeah, probably.
Beautiful.
Put Jim Cantore out there as well.
Brad Panovich, NBC Charlotte. I'm with Jim. I think that would be great. KML files would be awesome too for Google Earth. Be able to do that. What do you think is the most problematic part about winter weather forecasts? Is it the phasing of the streams? Is it the upper air data? It seems to me, like you said, you made a good point about all the moving parts, the pieces that make it difficult. What would you think would be the one thing that sticks out to you? And then I have a follow-up.
I really, I think, I don't know if it's the phasing per se. I mean, that's just sort of a generic problem we still have and we don't have. Yeah, let him answer.
This is what I think it is. It's just my opinion. Given the fact when you have a winter weather situation, especially out a few days, things kind of hone in on it as we get into about 48 hours. Sometimes. But you're talking about parts of the puzzle that come from way up into the Gulf of Alaska or way into the Pacific. So I think trying to time all those little parts when they don't have a good initial read on them, I think is a reason for some of that issue, that problem. But anyway.
And I do love the fact that with, like the HER, you can look at radar depictions of the forecasts that, they'll start looking more and more realistic. And we'll see some of the structures we really see in real time. They're just,
My
it's
follow-up
still
kinda-
sort of primitive.
Kind of is on that same train of thought. I think the interesting thing about winter weather forecasting is, do we kind of set ourselves up for failure? We try to get ultra specific for winter precip that we would never do for warm season precip.
See my hand?
And also, and this is probably more of a sociological, what is it with people in snow? I mean, it's like, I've never, I lived up north and I live in Charlotte now. It's just amazing how people just look at snow. Like you mentioned the word snow and you put a total out. They immediately disregard everything you say except for the highest number and the word snow. Where in reality, if I were forecasting, let's say, a spring system, and I would say scattered thunderstorms, I'm not trying to forecast a flash flood in a sub part of my county, but yet we do this in winter weather, where we try to forecast a snowburst.
That's the difference between user expectations and what we produce.
The reason is they can see 4 inches
Yeah.
of snow on their driveway. They can't see 3/4 of an inch of rain on their driveway.
And that's where also the charlatans that I mentioned, start telling us what we can do when we can't. Right.
Paul, Joe Murgo from WTAJ, and it kind of goes along the lines with that, but do you think there's actually harm in that, in the average person now getting access to models, but they're people will grasp, I mean, they're putting out a single model run of one amount, and I've had people tell me before, no, you're wrong, this is what the model says, but it's a single thing. You don't think that's hurting?
Well, but as Howie was even answering with storm chasing, what are you going to do? Are you going to legislate it? I don't think so. I mean, I think we're all trying to grapple with the same issue of everybody's got access to it, and everybody's got their own mouthpiece to get that information out. How you contain it,
It's
a
like,
toughie.
I hate to tell you, but some people are out there and they just want to get certain companies, I won't name companies, or certain individuals that they want to get more people to their blog. People will go to someone who will praise
like
every
I said,
storm as the
I'm
biggest.
not naming names.
Yeah. Always go to the people.
Yeah.
People will go to them, and they don't mind they're wrong 80, 90% of the time.
Because it doesn't necessarily matter, because there's so much information out there, it gets lost in the din. You know, you can claim whatever you want. We're accurate with everything. You know, the Farmer's Almanac is 80% accurate. What does that mean?
I appreciate those words coming from you, though, for the people who
okay.
are listening at home, too.
Matt Safino, KGW, and to follow up on Joe's point, I think it's a huge problem on social media, in particular on Twitter and Facebook, where somebody just takes a model output of whatever parameter, say it's snowfall, 8 days in advance, and and then that just gathers momentum, and it turns into, oh my God, there's going to be 20 inches of snow, and name the place. And there's no meteorological interpretation or interrogation of that data, of that field, at least not with that posting, and it's taken as reality, as it's going to be that way for certain. And like I said, there's no way of stopping that. Everybody's got a mouthpiece. You can't stop it, but I guess maybe what we might be able to do is bash them. Or just at least provide.
Here, you gotta come on in and say, I know you're hearing this other stuff, but this is what
Right.
I think.
Well,
This is
right.
why I think.
At least say, look, yeah, I mean, right, and put it out there. Say, look, this is way far in advance, and there's still
Right, and there's
a lot
still
of
always
uncertainty.
going to be authorities as well.
Yeah.
So with all this stuff, there'll be a few, hopefully, it'll work out, hopefully, where
Well, I
the
think-
best will rise to the top.
Yeah, that's right, because people will realize, well, that wasn't right, so
Yeah.
I'm just curious what other people in the room think about that issue.
Well, this is Dale Eck, Weather Channel, we deal with it in the fact that this stuff gets out there, and someone posts a, 196-hour GFS forecast, and, we'll go to these editorial meetings where program will go, well, what about that storm that's coming up? And we're like, okay, yeah, the GFS has it, and let's deal with it. And we will actually take it on. We'll go, look, we're going to talk. This is way out into the future. There's a model hinting at this, and Jim does it a lot, but the European is doing this, and there's a lot of uncertainty here. We'll even throw up the spaghetti plots and go, that's one, and let's look at where they're clustered. This one's here, and all the others are clustered down here. And so there are responsible ways of if it gets out there, and your news director will probably walk in and go, hey, I heard we're getting a big storm at day 8, and I think you can take that, and you can kind of make the person who posted that, if they have a name in the business, look stupid without saying it, and you can also say, responsibly, here's how I am interpreting that one model run, the ensembles, the European, the Canadian, we'll show models on the air. I mean, sometimes the people that work for me who have to put out the deterministic forecast don't like it, but I'm like, hey, it's a good way to help the public understand the uncertainty in our deterministic forecast.
Dale, Howard Bernstein, WSA. Let me just follow up on that, and I encourage all of you, when you get in these situations, I've been on the air saying, hey, there's chatter out there. I mean, I'm not going to ignore it, but I think if we acknowledge it and then explain what we're thinking, why we're thinking, it's actually to our benefit. Because it shows that we're paying attention, but I don't agree with what you may hear about a 10-inch snowfall. I just don't see it, if that's the example. Right. And hopefully, you're right when you do it.
Yeah, I agree. This is Brad Panovich, NBC Charlotte again. That's why I'm a big fan of ensemble forecasting, because for every person who picks the high-end ensemble run, they got to realize statistically the low one is just as equally probable as that other one. And I tell people all the time, and it's a comment on Facebook, let's pick the highest ensemble member and put it out there. When in reality, the zero ensemble member is just as likely. That's why when you go with the mean, you're better off. So I think you're right. You should approach it, but the ensembles are a good way to explain to the public, I think, of like, here's the probability. I think people get that. They understand the percentages. And that's why I love your guys' site now, because the chances, probabilities of 1, 2, 3 inches, that I think, it's 5%. It means it's 95% not going to happen.
Right.
Why are you dwelling on the 5%?
Right. It's good. Thanks.
Just a quick comment, and when I get frustrated too, I'll watch as you see it happen. You're watching everything transpire, but I'll give a Pollyanna point of view on this one. Isn't it great to work in a career where there's a room full of passionate people on the air going on, and Paul, your passion over your career with all this, that we have a product that people out there are passionate about. People that sell widgets for a living, God love them, but I mean, you don't see them going out there and posting things on Facebook pages or tweets. So I guess when it gets frustrating, I look at the science and the job that we do, and it's nice to have people out there that are so passionate about it, following it, that they want to see it. And we don't have all the answers yet, but I'll be anxious to see what happens over the next 20 years.
Yeah.
Jennifer Ocavina from WPSD. I think very common in the Mid-South and part of the Central Plains is we have very little lead time to a winter storm developing a lot of times when that low actually develops. And what is the percentage of accuracy you see in the models once the storm is actually developed compared to when it hasn't? Does that make sense? How accurate do the models become once?
Sometimes accurate, sometimes not. I'm thinking more in Central Plains because I know you're probably talking about the lows that come out of the Rockies and then they form. In a sense, they don't really operate all that much different than anywhere else. I just think it's varies from case to case. I know that's very unsatisfying. So, sorry. I do have like one thing I wanted, because I've always wanted, when I was on the Weather Channel, there was always one thing I really wanted to say. It's like, something big is building up and it's like, relax. It's going to melt in a few days anyway. That's what I wanted to say. Yeah.
Paul, this is Dave Jones with Storm Center Communications. I had a question. When we saw all of the forecasts involving Sandy with the different model forecast days ahead of time, and the talk was about the European model versus the GFS and all this, are you seeing similar accuracies that the European model has over any of our models here in the United States, or was it really focused on the tropical, sort of situation, or overall, are you seeing?
I would say it was overall, but I just know from listening to forecasters in my own organization, they're not so hot right now on the European. They think the Europeans having troubles, for whatever the reasons. So, none of these things are really set in stone, especially since the models are being updated all the time. Mm-hmm. Anyway, so, even what used to be true or perceived to be true, just wait 6 months or so.
And just a quick follow.
And Louis does run the Weather Service now.
Just a quick follow-up to that. As Chris showed in his presentation yesterday, the difference that a higher resolution model run made in Sandy's case, do you feel as optimistic in the winter weather forecasting area about higher resolution models, maybe detecting these banding features that you're saying are so surprising, sometimes with the intense snowfall rates. Do you see the higher resolution models helping to describe banding features better or locate banding features better?
Certainly that's the hope. That example I showed for Philadelphia this past winter is an example of that hope. It's not clear-cut, it's not seen in every case, but we certainly want to see more of that occurring. And I think that has been occurring, even in cases, I can remember back, I could swear I saw one model have the band in New York in 2006. I couldn't find it afterwards, but I know I saw it. So there is more and more information out there. It'll happen. I think you asked, what do you think? Yeah, I do.
Well, that's great. I think we have just 2 minutes left, and if there are no other questions, I'd like to give Paul a big round of applause for his... Thank you, Paul, very much. Let's take a look outside, live in Breckenridge right now. You can see that it is still cloudy. We have some snow still falling, and the temperature is still below freezing. I'd like to find out what the snow water equivalent is here for this. Maybe we had a 100th of an inch of liquid last night, but it was 12 inches of snow or something. So what we're going to do is we're going to break for lunch, and after the lunch break, I want to remind all of our viewers that they can come back online at 1:30 Mountain Time and ask questions directly to Dr. Howie Bluestein from University of Oklahoma about his research in tornadoes and what he talked about today, and also from Paul Kocin about winter weather forecasting. And so that should be a very exciting time. You can enter your questions in the Ustream chat window or tweet your questions to @WXC Summit. During the break that we're going to take here for lunch, please enjoy a National Geographic production called Earth Underwater, Sea Level Rise. And with that, unless anybody else has any other questions, we're going to break now, and we'll be back live with the question and answer session in about 90 minutes. Thank you so much for watching this morning. I do want to announce that we've surpassed the 4,000 viewer mark in the first 2 days of the Weather and Climate Summit, which is pretty awesome. So thank you very much for those of you watching online. Keep watching, keep tweeting out the address for where you can connect, and keep telling your friends, because this is exactly what we'd like to happen here at the Glenn Gerberg Weather and Climate Summit. So thanks very much. We'll see you back here in about 90 minutes.